Welcome to qnawire.
All right, in this question, we are asked to calculate the cell potential using the standard reduction potentials that you can find in your book. One thing to keep in mind here is when we're calculating E, the coefficients of your balanced reaction don't make any difference. So just to remind you of the overall equation that we're going to be using, you want to use that E cell standard equals the E cell or E reduction in standard conditions minus this cell potential of oxidation under standard conditions. So that's the equation that we're going to be using. So for this first reaction, we want to look to see how our oxidation numbers are changing so we know what's being oxidized and what's being reduced. So chlorine is going from 0 to -1. So chlorine is gaining electrons, so that's my reduction reaction. Iodine is going from -1 to 0. It's losing, it's being oxidized. So E cell is going to be the E reduction, and that's the chlorine. So you're going to need to look up your chlorine value on your reduction table, which is going to be 1.36 volts, minus the oxidation, which is the iodine, which is 0.54 volts, to give an E cell of 0.82 volts. On our next one, nickel here is 0. This is +4, this is +2, and this is +3. So nickel is going from 0 to +2. It's losing electrons. It's being oxidized. And then Ce is going from +4 to +3. It's gaining. It's being reduced. So E cell is going to equal the reduction potential. So that would be the Ce, and that's 1.61 volts. Again, you just look these up on the table in your book. Minus, and I believe it's Appendix E in the textbook, minus the oxidation. So that's a -0.28 volts. So we have minus and minus here. We're adding, so that's going to come to 1.89 volts. Our next one, we actually have iron is going to two different things. So here iron is starting at 0, and it's going to two different states of iron are going to one state. Here it's +3, and here it's +2. So in this case, iron is going from 0 to +2. It's losing electrons. Therefore, that's my oxidation reaction. And here, iron is going from +3 to +2. It's gaining. That's my reduction. So in both cases, you're looking for iron reactions. You just have to be careful of the signs of the charges. So for the reduction, you're specifically looking at the one going from +3 to +2, and that's going to be 0.77 volts. Minus the oxidation, which is iron metal going to Fe2+, and that's going to be a -0.44 volts for a total E cell of 1.21 volts. Finally, on this one, I have, I can see that my nitrogen's changing. If I solve for it, my oxidation number of nitrogen here, I would find it's +5. And here, since this is oxygen is -2, this must be +2. So in this case, nitrogen is gaining electrons. So this is my reduction reaction, going from nitrate to NO. And then my oxidation reaction is the copper. It's going from 0 to +2. So copper is losing electrons in that case. So that's my oxidation reaction. So my E cell is going to be equal to the reduction reaction, which is the nitrate reaction to NO. Again, you can even find that on your potential list. And that's going to be 0.96 volts minus the oxidation, which is the copper to copper-2+ of 0.34 volts for a total of 0.62 volts. And that's the end of that question.